Okay, part 2 of week 6. We're here with another equation of a tangent line problem, and we're going to talk about a normal line today too. Tangent line, still you need a slope for that, like we've been working on. So this equation is a little different now because we just learned a thing called implicit differentiation to find y prime, or the slope formula. So that's what we're going to do in this problem. So we're going to take the derivative of this. So the derivative of x cubed is 3x squared. The derivative of y cubed from up above, we learned, is 3y squared and then y prime minus, so now for this one, this is the product rule. So the first guy is 9x times the derivative of the second guy, which is y prime. The derivative of y is y prime, plus second guy, which is y, times the derivative of 9x, which is 9. Right, close off the parenthesis, equals derivative of 0 is 0. So now what we'll do is we'll simplify, and then what we'll do is we'll move, just like we did before, we'll move everything with a y prime on the left, and then everything without a y prime will move to the right. And we'll kind of factor these out. Well, we should be pretty good at this now. So we're going to factor out a y prime there. So it's 3y squared. And then factor out a y prime there, which is 9x. Everything else we're going to move the other side. So the 3x is going to become negative. 3x squared is going to become negative. And the 9y is going to be positive on the other side. So now we have our slope formula. We have y prime. So it's negative 3x squared plus 9y, and then over 3y squared minus 9x. So remember, slope is a number. So what we're going to do then is plug in the point. The point is 2, 4. So now you can see that our slope for the first time is when we actually get the slope number, it's actually a function of x and y. All right. So now you plug the slope in. So you plug in, for x, we plug in 2. And then for y, we plug in 4. And then on the bottom, same thing. We plug in 4 for y. So that should be 4, not y. Right? And then minus 9 times x. X is 2. So here we have 4 times negative 3, which is negative 12, plus 36 over, looks like 16 times 3, which is 48, minus 18. So what kind of number do we get? 24 over 30. So this becomes a fraction, it looks like. So our slope is 24 over 30. And you could take an, let me see, we can take looks like a 6 out of both of those. So it's 4/5, like. Okay, so it looks like our slope is 4/5. All right, I'm just checking my math here. Make sure we got everything right. Okay, so now since our slope is 4/5, what we'll do then is we'll do the tangent line first. So the tangent line is going to have the same slope that we found there. Okay, and then the normal line, which is different, that's going to have a perpendicular slope. So the normal line is kind of something different, and it doesn't really show you a whole lot. It's just a different type of problem. So the tangent line is the first one we're going to do. Tangent is the y guy is 4. Our slope is 4/5, and our x guy is 2 plus b. So 4 equals 8/5 plus b. So our b here, that's 1 3/5. So when you subtract it, you get 2 2/5 for a b. Okay. So then our equation of our tangent line is y equals 4/5, put an x there, and then our b is 2 2/5. The normal line will do down here. The normal line is going to have a perpendicular slope. So you use the same y and the x. So the y guy is 4. Our slope is -5/4. So it's different. It's going to be a perpendicular slope plus b. So 4 equals -8/4 plus b. So that's a -2. So it looks like our b is 6 for that one. So our normal line, we'll kind of squeeze down here, I'm running out of room, is y equals -5/4 x and then plus 6 for that. Okay. All right. So I don't know if I gave you another one to try there. So no, that was the only tangent line problem I gave you. Okay, so that's implicit differentiation. So now we actually go to kind of a different subject. You're still doing derivatives, and we're going to be doing derivatives for a little while. So when you do a derivative of a natural log, which is the first thing, it's this little formula there. And then the next thing is, this is the derivative of an exponential function. So this a is a number. Okay, that's a number. So you can see that this guy here, we're going to be using the second formula. Same thing over here. We're going to be using this second formula. So the first one is derivative of a natural log. The second one is the derivative of an exponential function. And the third one is the derivative of actually a log. Okay, so here's how you do these derivatives. So now we're just going to do some different types of derivatives. Not implicit differentiation or anything like that, okay? So here we go. The derivative of y is y prime. So now this is an exponential function. So you basically just follow this little formula here. So the formula is a to the u. So that just means you repeat this thing. And then ln of a is 3. Just put that down. That's a number. And then this du dx is the derivative of the exponent. So the derivative of 2x is 2. So when you write this, this one here, you really don't really do anything. You can't multiply natural log of 3 times 2. So you just kind of squish them together like that. And then you put the 3 to the 2x in parentheses. All right. Next one is very similar. Derivative of y is y prime. And then you do a to the u. So this thing repeats itself, sine of 2x. And then ln of a, ln of 5. And then you take the derivative of the exponent. The derivative of sine is cosine. Angle stays the same. And then the derivative of the angle, the derivative of 2x is 2. All right, so this has a lot of things in it. So we'll move it over a little bit. So we'll put 2 and then ln of 5. And then we'll put cosine of 2x. It doesn't really matter. The order, and then 5 to the sine of 2x. Okay? So that's a derivative of an exponential function. So the next one is a derivative of a natural log. So let's show you how that one works. So that one, follow that formula, derivative of y is y prime. So the derivative of a natural log, this is the way I think about it, 1 over that thing, okay? That thing, I call it, this is u, so I call it that thing, times the derivative of that thing. The derivative of x squared is 2x. The derivative of 1 is 0. The derivative always goes on top. Lots of times this thing you can't really do anything with. So that's the derivative. Okay. Next one, derivative of y is y prime. Derivative of a natural log is 1 over that thing times the derivative of that thing. The derivative of cosine is negative sine, angle stays the same. And then the derivative of the angle, the derivative of 3x, is 3. So that all goes on the top. So now you can simplify this a little bit. If you remember from some of your trig identities, and you don't have to do this, but it makes it look a little nicer. Sine over cosine is tangent, so it's actually negative tangent of 3x. And then this 3 we're just going to put in the front there. So it's actually negative 3 tangent of 3x. All right, so let me go back and fix that, negative 3. So sine over cosine is tangent, and then I just put the negative with the 3, and you're done. So that's how you do the derivative of a natural log. So now, if you look at the next one, number 12, this is the quotient rule, but we're doing derivatives of natural logs. So now you have to remember how to do the quotient. All right, so here we go. Quotient rule starts with bottom guy, derivative of the top. The derivative of a natural log is 1 over that thing, and then the derivative of x is 1, all right, minus. So bottom derivative of the top minus top. Derivative of the bottom, derivative of 1 is 0. The derivative of a natural log, once again, is 1 over that thing, and then the derivative of x is 1. All over bottom guy squared. All right, so now we're actually going to multiply this thing out and kind of show you what actually happens, or maybe you can kind of see it for y prime. You're going to have things that cancel. So 1 over x times 1 over x. 1 over x times natural log is natural log of x over x minus, and then this thing you can see will be natural log of x over x. So that those are actually going to cancel. So 1 plus ln of x squared. All right. So now on the top you just have 1 over x. On the bottom, you have 1 plus ln of x squared. What we're going to do is we're going to multiply top and bottom by x. So when you do that, when you multiply top and bottom by x, that gets rid of the complex fraction, like that. So that's what you should do. You should multiply top and bottom by x to get rid of the complex fraction. Okay? All right, next one. This is a different rule. This is actually the chain rule. Okay, so let's show you how this one works. The derivative of y is y prime. So now for this one, you do 4 times 1, which is 4. ln of x goes to the third power. And then you do the derivative of the inside. The derivative of a natural log is 1 over that thing, and then times the derivative of that thing. The derivative of x is 1. This one was fairly simple if you knew to do the chain rule. And that's all you can do for that one. Just kind of squish it together, and then the x goes on the bottom from that. Okay, so that's how you do the derivative of a natural log. All right. Okay, this one and the next one are some of the rules for expanding logs and natural logs. So this one, if you would follow that formula that I just kind of showed you, would be very difficult. But since this natural log in number 14 goes with the top and the bottom, it's kind of in the middle. So that actually means it goes with the top and the bottom. What you can do is you can kind of distribute this natural log. So we're not actually taking the derivative yet. We're just kind of splitting it up. Right? So if you remember one of the rules of expanding natural logs, division means subtraction. So this thing here is to the 5th power. Okay, so I'm not going to write it here. So this thing is to the 5th power. So one of the things you can do is you can move this power down in front like that. So one of the rules for expanding logs and natural logs is you can move that exponent back in front. And then since it's division, it's minus. All right, now the next thing is this 1 minus x. So this is square root, which means half power. So what we're going to do is we're going to put that half power in the front there like that. So now we're able to take the derivative much simpler when you kind of did that. So the derivative of y is y prime. 5 comes along. The derivative of a natural log is 1 over that thing times the derivative of that thing, which is 2x. Minus 1/2 comes along. Derivative of a natural log is 1 over that thing. Now be careful, the derivative of that thing is -1. And that's pretty much all you need to do for this one. Just combine like terms. So 5 times 2x is 10x, and then over x squared plus 1. All right. So let me do that. That'll be 10x over x squared plus 1. And then this will become plus. 2 negatives make a positive. And then you don't have to multiply this through. You can just kind of leave it go like that. Just leave it, go. Okay? So that's one where you had a natural log and there was a division sign, which means subtraction. So now this one also would be difficult, 15. if you tried to do it, based on that formula. So this one is multiplication, which means addition. So what we're going to do is we're going to expand this. So the first thing is ln of x squared, and then plus ln of tangent. Okay. So multiplication means plus. Now this 2 here, you could move it in front if you wanted to, or you can leave it back there. It really doesn't matter. It doesn't really make it any easier or harder and that kind of thing. So whichever you prefer. I'm just going to leave it there just because I don't have to write anything anymore. So the derivative of a natural log is 1 over that thing times the derivative of that thing, which is 2x, plus derivative of a natural log is 1 over that thing. And then the derivative of tangent is secant squared. The derivative of the angle x is 1, so you don't have to add anything, okay? So y prime is, these x's are going to cancel here, so you're going to have 2 over x plus, and then this thing you can't really do much, so we'll just kind of leave it go, secant squared over tangent. Okay. All right. So that's the derivative of a natural log, where you have to expand them. So if you see a division sign with a natural log in front of everything, you want to expand it. Same thing, if you see a natural log in front of things that are multiplied, you want to add them. You want to expand them like that. Okay. Now for number 16, this one's a little different, and 17. So these, you can see there's no natural log. This is really complicated. So this is called logarithmic differentiation. So the directions have to specifically tell you to do this problem by logarithmic differentiation. So what we're going to do is we're going to actually add a natural log to both sides. So we're going to add a natural log there, and then we're going to add a natural log here, right? So this is a cube root, so we're going to kind of write this a little differently at the same time, all right? So it's x cubed plus 1, and then the whole thing is a cube root, so we'll just write it to the 1/3 power. So we kind of did two things at once. So logarithmic differentiation, what you do first is you take the natural log of both sides. So what that enables you to do, it enables you to split this natural log apart, okay? So this side stays the same. That doesn't change. This 1/3 can come in front, right? Whoops, 1/3. And then what we're going to do is, just like we did before, we're going to expand this. Okay, so we'll put a little parentheses there. So the first thing is natural log of x. Multiplication means plus. So then the next thing is natural log of x minus 2. And then since it's division, it's minus natural log of x cubed plus 1. Right? And then we'll close it off. So this 1/3 will just go with everything. So now we can take the derivative of both sides. So you have to take the derivative of both sides. Now this is where it's a little bit different. Remember, the derivative of a natural log is 1 over that thing times the derivative of that thing. The derivative of y is y prime equals 1/3. Okay, now we do the derivative. The derivative of natural log is 1 over that thing. Derivative of that thing is 1. Derivative of natural log is 1 over that thing, and then the derivative of this is 1. So it's pretty easy once you get all this expanded. Derivative of natural log is 1 over that thing, and then the derivative of that thing, so here we have something, is 3x squared. Close it off. Okay? So now what we're going to do is we're going to solve for y prime, because that's what we're trying to solve for. We're trying to figure out the derivatives. So what we're going to do is we're going to multiply both sides by y. So this will be 1/3 and then y, and then this will stay the same. 1 over x plus 1 over x minus 2 minus, and then 3x squared. We'll just combine it, x cubed plus 1. So the last thing you have to do with this problem, and I'm just going to kind of draw an answer. What you should do is write your answer over. So now you can see our answer, our derivative, y prime, we got alone, has x's and y's in it. Well, this is okay, but actually, if you look up above, we can actually do a little better, okay? This thing up here is y. So what you want to do is you want to put this whole equation in for y right there. Right? So there's a y. So what you want to do on the test is you want to write 1/3, and then you want to put this thing here where the y is, and then write the rest of the equation down, and then you got your answer. Okay? So one more on logarithmic differentiation, and then we'll stop the video. Okay? So this one here is a similar kind of problem. All right? So what we'll do is we'll take the natural log of both sides. So now when we take the natural log of this one, we'll write x squared plus 1, and then x minus 4, and then this whole thing, whoops, this is cubed. This is cubed, can't forget that. And then we'll need a parenthesis. This whole thing is to the half power. It's to the square root. So kind of the same thing. What we'll do is we're going to expand it. This 1/2 can go in front like that, and then ln, so we'll put a little bracket there. And then the first thing is this x squared plus 1. And then since it's multiplication, that means a plus. So now this 3 is going to go in front here, and then we'll have natural log of x minus 4, like that. So this natural log gets distributed to both of them, and then it's plus because it's multiplication. Okay? So now we're ready to take the derivative of both sides. All right, the derivative of natural log is 1 over that thing times the derivative of that thing equals 1/2 times the log. The derivative of natural log is 1 over that thing times the derivative of that thing is 2x plus 3 comes along. The derivative of natural log is 1 over that thing, and then the derivative of that thing is 1. Okay? So same thing that we did last time is we're going to solve for y prime because that means derivative. So y prime equals 1/2. Move the y over there, multiply both sides by y, and then we'll just kind of simplify this. So 2x over x squared plus 1. And then the same, same thing with the 3. Okay? So plus 3 and then x minus 4. And then what you want to do is you want to put in that thing up above for y. Erase that, make a bracket. Okay. So now you want to put this thing in for y. All right. So on the test, make sure you put this thing right in here in for y, right there. All right. And we have one more logarithmic differentiation problem, okay? And then the next part is derivatives of logs, which is just a formula. So ln of y equals ln x to the 3x. So now remember, an exponent with a log or a natural log, you can move out front, 3x ln of x, like that. So now the derivative of both sides, the derivative of natural log is 1 over that thing, derivative of that thing equals. So now here we have the product rule, okay? So first guy, derivative of the second guy is 1 over x plus second guy, and then the derivative of 3x is 3, all right? Move up here, solve for y prime, so y prime equals multiply both sides by y. So you have a y here, and then you have this x will cancel. So you actually here just have a 3 plus 3 ln of x. And you're basically done. So here on the test, like I said, y is x to the 3x, and then 3 plus 3 ln of x. And you're done. Okay? So you want to make sure you fill in what y is after you solve for y prime. Okay? All right. So that's probably the hardest part of the lesson is logarithmic differentiation.